So up until this point, we've talked about ionic compounds, which ionic compounds have to do with the transferring of electrons. They are between a metal and a nonmetal. But now what we're going to do is we're going to talk about covalent compounds. And covalent compounds are between two nonmetals. So a nonmetal and a nonmetal is a covalent compound. And when naming them, you name the first element. The first element keeps its name. So, similar to ionic compound, the first element will keep its name. The second element gets "ide" ending. So, this first two rules to naming covalent compounds are actually the same as ionic compounds. The only difference is that with covalent compounds you use Greek prefixes to identify the number of each atom. And this makes it so easy because before, when we were coming up with the formula for ionic compounds, we would balance the charges. But in this situation, we do not need to balance the charges because the name actually tells us how much is in each formula. So you need to use Greek prefixes when naming the compound. So here's an example. So this is, there's two nitrogens here. So the first element keeps its name. So it's going to be nitrogen, but it's not just nitrogen, it's dinitrogen. All right, it's dinitrogen. And before we continue, let's go ahead and go through the Greek prefixes here. So we have mono. Mono means one. Di means two. 3 is tri. 4 is tetra. Penta is 5. Hexa is 6. Hepta is probably the one that most people forget, is 7. Octa is 8. Nona is 9. And deca is 10. So when we're naming it, there's two nitrogens, so it's dinitrogen. There's one sulfur, so it's mono, and instead of sulfur, it's sulfide, monosulfide. So dinitrogen monosulfide. Now, in this next one, though, there is one exception. There's one time where you do not add a prefix, and that's if the first element is 1. The first element will not get mono. However, the second element will get mono, but the first element will not get mono if it only has 1. And so this here has 1 sulfur, so it's just sulfur. And then trioxide. And so here, notice how there's no mono, but the second one does get mono. So let's go ahead and let's give these a shot here. So dichlorine, there's 2 chlorines, monoxide, 1 oxygen. Bromine, okay, so there's no prefix here, so that means there's 1. And then hepta means there's 7, so it's heptafluoride. Carbon, again, no prefix means there's 1, and it's tetrahydride. All right, let's go ahead and name these here. So 5 is penta. So it's penta bromine. And then trifluoride. Instead of fluorine, we change it to fluoride. So again, the first element keeps its name. The second element you change to "ide." All right, next one. Disulfur. Hexahydride. Instead of hydrogen, it's hydride. All right, and then pause the video, try to do this last one on your own. What is the name of this last one? Trisilicon. Diiodide. And this is one of those rare words that has 2 I's in a row. It's really weird. All right. Now you try these on your own. Give it your best shot. Let's go ahead and talk about covalent Lewis dot structures. And so Lewis dot structures for covalent compounds show how the electrons are shared within a molecule. And this is a method to show and verify if each atom has a full octet. Now there are a couple exceptions. Hydrogen is okay having 2 electrons in its outermost energy level, and boron is okay with 6 electrons. All other atoms want to have 8 though. All atoms want to have 8 electrons in their outermost shell. Now covalent compounds are when a nonmetal bonds with a nonmetal, again, and there is a sharing of electrons. So let's go ahead and take a look here. So what we want to do in these examples is we have bromine. Bromine has 7 valence electrons. All right, then bromine has another, there's another bromine here that has 7 valence electrons. And what I'm going to tell you is it's the single electrons that are involved in the bonding. And so notice how each bromine has 1 single electron, and so each bromine will make 1 bond. And so what I'm going to do is I'm going to divide this in half just for this first one here and show you kind of what happens. So this bromine is like this. This bromine is like this. And all you do is you make the single electrons face each other, and there's the bond. Notice how there is a single bond there, and notice how in one bond there's 2 electrons. And I'm actually not going to do anything down here. All right, hydrogen has 1 single electron. Chlorine has 7 valence electrons. Again, this has 1 single electron, so it'll make 1 bond. This has 1 single electron, so it'll make 1 bond. And just like before, what we do is we write them to where the single bonds are facing each other, just like this, and then we make them bond. And now they're sharing those electrons. All right, next one. So boron has 3 valence electrons. Fluorine has 7 valence electrons. Notice how this has 3 single electrons, so it will make 3 bonds. This has 1 single electron. But notice the formula tells us it's got 3 fluorines in there. So the way we do this is we write the central atom, which the central atom is always going to be the one that is the fewest number. So boron only has one atom, so whichever one is the fewest number of atoms is going to be the central atom. Then what we want to do is we want to take these 3 fluorines and we want to spread them evenly throughout around boron there. And so all 3 fluorines will be bonded to boron, and we want to be as far apart as possible. So this is what you don't do. So don't write this down. You don't do this. Do not do this, because you can make them even more far apart, and you want to make them equal. Give them all equal amount of distance between each other. So you can go like this. And so here we go. And actually I'm going to go like this because boron has these 3 valence electrons. I'll just go like this. And there we go. And then this one here. All right, so this makes a bond, this makes a bond, and this makes a bond. And so notice how boron's making 3 bonds. Notice how fluorine is making 1 bond. All right, carbon, 4 bonds. 4 single electrons, 4 bonds. Now hydrogen only makes 1 bond, but notice how we have 4 hydrogens. So again, we put carbon in the middle. We surround it with hydrogens. And again, we want to try to put the single electrons to where they're facing each other. And this makes a bond, this makes a bond, this makes a bond, and this makes a bond. And there it is. All right. Now this one, if you take a look here, this is one where I'm going to divide it. So each oxygen has 6 valence electron. Notice how it has 2 single electrons, so that means it'll make 2 bonds. And so the way this works is this is actually going to form a double bond with each other. So this is going to bond and this is going to bond. And so this will form a double bond. And I'm going to rewrite this like this, kind of clean it up a little bit. And that's what it looks like. And then we have nitrogen. Nitrogen has 5 valence electrons. It has 3 single electrons, so it'll make 3 bonds. Iodine has 1 single electron, but notice how there's 3 iodines. So we're going to evenly spread them out. Notice how I'm positioning them to where they can make that bond with the single electron. Bond, bond, and bond. And it's that simple. If you guys have any questions, feel free to email me. Have a great day.